All right, we are starting a new unit and we are going to talk about factors and greatest common factors. So this is page 11.1. The substitute should have handed you that packet. Right now, we're just going to talk about what we multiply together to get numbers. So first, we're going to talk about a prime number. A prime number is a whole number, that's just a regular 1, 2, 3, 4, 5, 6, 7, greater than 1, whose only factors are 1 and itself. Okay, so an example would be 2, because the only thing I can multiply together to get a 2 is 1 times 2. I can't do anything else. A 7 would be a prime number because the only thing I can multiply to get a 7 is a 1 times 7. But a 6 would not be a prime number because I can multiply 2 times 3 or 1 times 6. So do you see the difference? So a composite number is a whole number greater than 1 that has more than 2 factors. So 6 works, 12 has a lot. It could be 1 times 12, 2 times 6, 3 times 4, okay? So prime numbers can only be multiplied by itself in 1. Composite numbers can, lots of things, can multiply them together. We are going to identify all the prime numbers on this chart. You will use this throughout the rest of the lessons, so be sure that you do this well. So, first of all, 1. That is not prime, and it is not composite. It doesn't count. So, we're going to circle the prime numbers. Well, 2 is a prime number because it can only be multiplied by itself, and 3 is a prime number because it can only be multiplied by itself. It's actually easier. Let's mark out the ones that aren't prime. Anything that has a 2 in the end is any even number is not going to work because I can multiply 2 to get it. So I'm going to go ahead and mark out all my even numbers. Pause it and mark out all your even numbers. All right, now that I have all my even numbers marked out, I'm going to mark out anything. Well, we know that 5 is only 1 times 5, but everything else with a 5 at the end, I'm going to mark out because it means I can multiply it by 5. All right, let's see. 7 is prime because nothing will multiply by it. 9 is not because 9 is 3 times 3. 11, prime. 13, prime. 17, prime. 19, prime. 21 is 3 times 7. 23 is prime. 27 is 3 times 9. 29 is prime. Let's see, 31 is prime. 33 is 3 times 11. 37 prime. 39 is 3 times something. 41 is prime. 43 is prime. 47 is prime. 49 is 7 times 7. 51, I can multiply 3 to get something prime. Nope. Prime. All right, I'm going to mark the rest of these. 61 is prime. 71 is prime. These I can multiply to get a number. 73 is prime. 83 is prime. That is not prime. No, no, prime. No. Prime, prime, no. All right, be sure that your chart looks like my chart. All right, now we are going to list all the multiplication problems whose answer equals a 36. So 1 times, 36 equals 36. 2 times 18 And what you can do is say 36 divided by 2, and it tells me it's 18, okay? 3 times 36 divided by 3 is 12. 4 times 9. 5, that does not work. 6 times 6. So all the factors of 36. Well, I've got 1, 2, 3, 4, 6. So I went 1, 2, 3, 4, 6. And now I'm going to go backwards. I've already written the 6. 9, 12, 18, 36. All right, so that is a composite number. It's got lots of factors. Prime does not. 1 times 23 makes a 23. 2 times doesn't work. 3 times doesn't work. So the only factors are 1 and 23. So they always have themselves and a 1, prime and composite, but then composite has all the other stuff between it. So prime factorization is when a number is expressed as the product, that's a multiplication answer, of factors that are all prime numbers. So we are going to do a factor tree, and so I do it like this, and I'm going to say, what times what gives me 90? Well, I know that 9 times 10 gives me 90, and I need to look back. 9 is not prime, but 3 times 3 gives me 9, and those guys are prime, so I circle them. 10 is 2 times 5, and when I look at my chart, 2 and 5 are prime. So the prime factorization of 90, I'm going to write them in order. 2 times 3 times 3 times 5. 88. Well, I know that 8 times 11 gives me 88. 11 is circled because it is prime. 8, I can do 2 times 4, and 2 is prime. And 4 is 2 times 2, and those guys are prime. So everything ends with circles, so I can say 2 times 2 times 2 times 11. And if you type that in your calculator, you would get 88. 100 is 10 times 10, and 10 is 2 times 5, which are both prime. Wow, 2, my pen's not writing, times 5. So the prime factorization is 2 times 2 times 5 times 5. 21, I know that I can do 3 times 7, and then that's all. They're both prime, so that one was easy. All right, you do negatives almost exactly the same way, except you have to put a -1 times the original one first. So let me show you what I mean. So -140 is -1, which I'm going to circle, times 140. Now I'm going to break down 140. I'm going to say 10 times 14. That is 2 and 5. Whoops. And 14 is 2 and 7. So I've got everyone down to their primes. So -1 times 2 times 2 times 5 times 7. -30 is -1, go ahead and circle it, times 30. 3 times 10, 2 times 5. -1 times 2 times 3 times 5. -14 is -1 times 14. 2 times 7, and I've gone as low as I can go. Okay, so that's how we do prime factorization. Now, we're going to factor monomials. So now I'm throwing in some letters and numbers for you, but it's okay. So you're going to factor the numbers, numbers, and you're going to write out the letters. It's not hard, I promise. So let's just look at the numbers right now. 12, I'm going to do 3 times 4. 3 is prime, 2 times 2. All right, so I have 2 times 2 times 3. And then the A, I've got 2 A's, so A times A, and I got 3 B's times B times B times B. All right, let's do this one. I've got a negative 66. I'm going to go ahead and do a negative 1 and a 66. That would be 6 and 11. 11's prime, 3 times 2. All right, I've factored all the way down, so negative 1 times 2 times 3 times 11. I got 1 P, so times P. And I got 2 Q's, times Q times Q. All right. We are going to find the greatest common factor, and that is the product. And again, we're talking about multiplication of the common or same factors of 2 numbers. We'll multiply all the similar factors to get the GCF. Okay, so we're going to do exactly what we've been doing. I'm going to take the 48 and I'm going to factor it. That gives me 6 times 8, 2 times 3. That's 2 times 4, and 4, whoa, that would be a 2 times 2. 2 and 2. Okay, do I factor the 48? Just like I have been, I'm going to write 48 right here. And I'm going to write 1, 2, 3, 4. I got 4 2's. 1, 2, 3, 4, and a 3. Okay, now I'm going to do the 60. That's 6 and 10. That is 2 and 3. And that is 2 and 5. Okay, so 60, I got 2 times 2 times 3 times 5. Now, I'm going to circle what is in both groups. So there's a 2 in both groups and another 2 in both groups, and I see a 3 in both groups. So your GCF is, I'm going to take one group of 2, another group of 2, and the group of 3. So it's 2 times 2 times 3, and when you do that in your calculator, you get a 12. To find the GCF of a monomial, you're going to list their common factors and common variables. That says BLES, and multiply the similar factors and list the similar variables. Okay, so 36. 36, well, 6 and 6, 2 times 3, 2 times 3. Okay, so I have my 36 equals 2 times 2 times 3 times 3, and then I've got x, x, y. Okay, 54, let's do 6 and 9, 3 and 2, and 3 and 3. So 54 is 2 times 3 times 3 times 3, and this one has 1x, 2 y's, 1 z. Okay. I'm going to circle what's the same. 2, I got a 3 and a 3, an x and a y. Perfect. All right, so these are the things that they have that are the same. So the GCF would be 2 times 3 times 3 times x times y. And that gives you 2 times 3 times 3 is 18, x, y. Numbers are what we call relatively prime if the only GCF of the 2 numbers is 1. Okay, so let's see what I'm talking about. 15. Well, that's 5 and 3 prime, 16. That would be 2 and 8. And then that would be 2 and 4 and 2 and 2. So 15 is 3 times 5. 16 is 2 times 2 times 2 times 2. Well, there's nothing I can circle together. There's nothing that's the same. So it means that these guys don't have a GCF because they are relatively prime. All right. I need you to do page 11.4 and 11.5. Do all of those, and then you have a Delta Math 11.1. Thank you.